We are going to look at distributive next, which should be familiar from algebra. It holds true just the same in Boolean theorem. Now, if we have an equation that looks something of this nature, where we have x and y or z, that would be equivalent to saying we have x and y or x and z. Now let's look at this drawn out with gates. So first we would evaluate our or here between our y and our z. Then we would evaluate our and between our x and the result from y or z, producing our output. Now what's interesting is note how many gates we use here. 2 gates. Now let's go ahead and draw out the equivalent equation. We have 2 AND gates here, as we have x and y here, and we have x and z down here. And then both of these feed down into an OR gate to produce our result. Now here we have 3 gates. And the reason why I think this is one of the most important examples for beginners to look at is this is the first time we really start to see the power of using these theorems in real time. Because imagine if you were producing this circuit in the real world. You have now reduced your requirement from 3 gates down to 2. Think of that on a much larger scale, and you can start to see the power of this.